Imagine our galaxy, the Milky Way, a vast, spinning city of stars, gas, and dust. We live on a tiny blue planet in one of its quiet arms, long believing the galaxy was serene and predictable. But new discoveries reveal a far more dynamic and chaotic reality. There's a colossal disturbance, a great galactic wave, rippling through the stellar disk. This isn't a wave you can see, it's measured in light years, involving millions of stars moving in a coordinated, mysterious motion. The discovery has upended our assumptions about the Milky Way's stability. It hints at a violent, eventful history, marked by collisions and unseen forces. If the Milky Way were a city, this wave would be a tremor shaking entire districts. In reality, it's thousands of light years across, with stars rising and falling over millions of years. What could cause such a ripple? What does it reveal about our galaxy's hidden architecture? The Great Galactic Wave is a clue to our cosmic origins, a story just beginning to unfold. The universe is alive, evolving, and full of surprises. We are explorers, and the map of our galaxy is being redrawn before our eyes. How did we find this invisible, colossal wave? Enter Gaia, the European Space Agency's revolutionary star mapping spacecraft. Gaia's mission: create the most precise 3D map of the Milky Way ever attempted. It's charted the positions, distances, and motions of nearly 2 billion stars, transforming our understanding. Before Gaia, our view was flat, like seeing a city from a single photo. Gaia measures parallax to calculate distances and tracks stars' motions across and through space. This gives us a 6-dimensional map, revealing the galaxy's true dynamic structure. We can now see rivers of stars, clusters moving together, and crucially, the subtle bobbing of millions of stars in a gigantic wave. Astronomers noticed stars in a vast region weren't just orbiting, they were moving up and down in a coordinated pattern. The effect is subtle, but unmistakable, and spread across a huge area. Without Gaia's precision, this ripple would have remained invisible. Gaia gave us the glasses to see a galaxy that's wrinkled and ringing like a bell. The Milky Way is not flat and calm, but alive with hidden motion. Our understanding of the galaxy has changed forever. What does a wave made of stars look like? Not like ocean waves, stars are far apart, never colliding. This is a density wave, a ripple of motion passed along by gravity. Stars move up and down in place, like a stadium crowd creating a Mexican wave. Imagine a lake at night covered in glittering lights. A distant splash sends a ripple. Each light bobs up, then down. That's the Great Galactic Wave, millions of stars undulating above and below the galactic plane. The wave forms a spiral, not a simple circle, twisted by the galaxy's rotation. It moves at about 500 km per second, but the galaxy's size means it takes hundreds of millions of years to cross. We're seeing a snapshot of a process unfolding over eons. The wave's amplitude is a few hundred light years. Stars at the crest are that much higher than those in the trough. Our solar system is currently riding this wave, moving upward through the galaxy. We are participants in this cosmic dance, surfing a wave of stars. The Great Galactic Wave is a physical structure we can measure. It's a reminder that we're part of a living, moving galaxy. Whether we notice or not, we're carried along by this immense gravitational swell. What could create such a massive wave? Astronomers suspect a dramatic collision. The Milky Way is surrounded by smaller dwarf galaxies. One may have plunged through our disk like a stone in a pond. The Sagittarius dwarf galaxy is a prime suspect, having passed through our disk multiple times. Its gravity could have dragged stars, creating the initial disturbance and spiral wave. Another theory: a dense clump of dark matter passed through, its gravity alone enough to set the stars in motion. Or perhaps internal processes, giant gas clouds within the Milky Way, triggered the ripple. By studying the wave's shape and speed, astronomers hope to identify the true culprit. The next great challenge: rewinding the clock to reveal the event that shook our galaxy. The Great Galactic Wave isn't the only vast structure in our galactic neighborhood. The Radcliffe Wave, a 9,000 light-year chain of star-forming clouds, was discovered nearby. Unlike the Great Galactic Wave, which is a ripple in stars' motion, the Radcliffe Wave is a string of gas and dust, birthing new stars. Both were revealed by Gaia, showing our galaxy isn't flat, but undulating and three-dimensional. Are these waves related? Perhaps a galactic collision triggered both, or they're separate signs of a dynamic galaxy. The Great Galactic Wave is larger and older. The Radcliffe Wave is more local and recent. Together, they reveal a galaxy shaped by multiple forces across time. These waves are more than curiosities, they're keys to understanding the Milky Way. Mapping our galaxy from within is like charting a forest from the middle of the trees. Waves act as diagnostic tools, like seismic waves revealing Earth's interior. By studying their movement, we learn about the galaxy's mass, density, and gravitational field. The Great Galactic Wave is a scar from a past collision, a measurable echo of our galaxy's violent history. Rewinding the wave helps pinpoint when and where the impact occurred. We're not passively orbiting the galactic center. We're part of a dynamic, ever-changing environment. Our solar system rides the crest of this giant wave, connecting us to the galaxy's story. Everything in the universe is linked by gravity, from falling apples to the majestic dance of stars. We're living in a remarkable era. Gaia has revealed the Milky Way's hidden motions and violent past. We've found a colossal wave of stars, evidence of a powerful event that shook our galaxy. Theories abound: a dwarf galaxy, dark matter, or internal galactic weather. But the true cause remains elusive. Each answer leads to deeper questions, redrawing the map of our cosmic home. The Great Galactic Wave is a starting point, inspiring new generations to explore further. We are tiny observers, carried by a current of stars we're only beginning to perceive. The universe is always more intricate and wonderful than we imagine. As we gaze at the Milky Way, we're left with a mystery. What, exactly, hit our galaxy?